Hello everyone, welcome back. For this lesson, we're going to look at hypothesis testing for the difference between two population means, and this is called a two-sample t-test. And the assumptions and conditions that are required for performing the test is the same as the two-sample t-interval that we covered from the previous lesson. Okay, so recall that we had the independent responses and independent groups assumptions, as well as the normal population assumptions. Now, for the null hypothesis of the two-sample t-test, we will be looking at the difference between the two population means, so mu1 minus mu2, and this will be equal to some hypothesized difference, in which we will call this d naught. And in most cases, this value will almost always be 0. Now, there are some situations where you may know what the difference should be between the two population means, but generally we will typically let the value be equal to 0. Okay, so we will hypothesize that there is no difference between the two population means, so that mu1 minus mu2 would be equal to 0. Now, to find our test statistic, we will look at standardizing our t-score. So we do this by finding the difference between the two sample means, so y1 bar minus y2 bar. We will subtract the hypothesized difference, which will typically be 0, and then we will divide by the standard error. And recall that the standard error for the difference between two means is given by this square root formula. Now, when those conditions are met, then the test statistic will follow a student's t-distribution with a certain number of degrees of freedom. Okay, so now recall that the way that we'll find the degrees of freedom is by using this method where we take the smaller of the two sample sizes minus 1. Okay, so our sampling distribution model will be a t-distribution, and we will use this model to obtain our p-value, which is the probability to observe the test statistic, or more extreme than this test statistic. So recall that the p-value will depend on the type of test we are performing. So if we're looking at a upper tail test, right, so the alternative hypothesis is in the upper direction, then we want the area in the upper tail, okay, or the right tail. If we're performing a lower tail test, so the alternative hypothesis is in the lower direction, then we want the lower tail or the left tail. And if the alternative hypothesis is two-tailed, okay, so it does not equal d naught, then we want the area of both tails. Okay, so let's have a look at an example of a two-sample t-test. So triglycerides are a form of fat found in the body. Using data from a national health survey, we have the following results comparing the triglyceride levels in men and women. For a sample of 44 women, the average triglyceride level was 84.4 with a standard deviation of 40.2. For a sample of 48 men, the mean triglyceride level was 139.5 with a standard deviation of 85.3. So let's carry out a hypothesis test using a 1% significance level to determine whether men have a higher mean triglyceride level than women. All right. So let's first introduce some notation. So we're going to let mu sub m, okay, so mu sub m, this will be the mean triglyceride level for men, and mu sub w will be the mean triglyceride level for women. Okay, so now let's have a look at writing down the hypotheses. Okay, so we have the null hypothesis and the alternative hypothesis. Okay, so what we are trying to test is whether or not men have a higher mean triglyceride level than women. Okay, so this will indicate what our alternative hypothesis should be. Okay, so if men have a higher mean triglyceride level than women, okay, so now let's suppose we took the difference between the mean triglyceride level of men and the mean triglyceride level of women. Okay, so mu sub m minus mu sub w. If we want to test that men have a higher mean triglyceride level than women, then mu sub m is going to be larger than mu sub w. Okay, so the average for men should be higher than women. If I were to look at the difference between mu sub m minus mu sub w, all right, now because mu sub m is going to be larger than mu sub w, then their difference should be a positive number. Okay, so mu sub m minus mu sub w should be greater than 0. All right, so that is our alternative hypothesis. Now this would tell us that our null hypothesis is that mu sub m minus mu sub w should be equal to 0. Okay, so we hypothesize that there is no difference between the mean triglyceride levels for men and women. So now the next step is to check the assumptions and conditions required for the test. So we have independent responses. All right, so we're looking at the triglyceride levels of each person. So within each of the groups, the triglyceride level of a person should not affect the triglyceride level of other people. Okay, so they are independent of one another. And we also have in the independent groups assumption. Okay, so the groups must be independent of each other. So what this means is that the triglyceride level of a woman should not affect the triglyceride level of men and vice versa. Okay, so the triglyceride levels of men should not affect the triglyceride levels of women. So now to check for the independent assumptions, we'll look for randomization. Now we're not given that the samples we've collected are random, so we need to assume that the samples are representative of the target populations. Okay, so not given random samples, so we assume that the samples are representative of the target populations. Okay, now the other assumption is that the populations should be normally distributed. And we will check the nearly normal condition. So the sample distributions should be nearly normal, so unimodal and symmetric. or the sample sizes should be at least 30. Okay, so we can use the central limit theorem if our sample sizes are large enough. Okay, so what we have is a sample of 44 women and 48 men, which are both greater than 30. And so we can assume that this condition is met. Okay. So now the next step is to find our test statistic. And the test statistic is calculated by taking the average between the men minus the sample average from women. We subtract the hypothesized difference, okay, and that's the value in the null hypothesis, which we have equal to 0. Okay, so we subtract 0, and then we divide by the standard error. All right. So now to find the standard error, we will take the square root of the standard deviations squared divided by the sample sizes. Okay, so we want the square root of, so the standard deviation for the men is 40.2. Okay, we square that, then divide by the sample size, which is 44. Oh, I guess these are actually the values for women. So let's just fix this. Okay, so for the men, the standard deviation was 85.3 squared over 48 plus 40.2 squared divided by 44. All right, and this will give us a standard error of 13.7227. Okay, so now we can find our test statistic. Okay, so we want to find the average in the males minus the average of the females. So what we have is 139.5 minus 84.4 divided by the standard error, which is 13.7227. Okay, now if we round this to 3 decimals, our test statistic is 4.015. Okay. So now we need to look for the number of degrees of freedom. Okay, so to find the degrees of freedom, we take the minimum of the sample sizes minus 1. So this will be the minimum of 48 minus 1 and 44 minus 1. So the smaller of 47, and 43, which will give us 43. Okay. All right. Now just okay. Nope. All right, so what we have is 44 degrees of freedom. Oops. Or 43 degrees of freedom. And our test statistic was 4.015. Okay, so now to find the p-value, right, what we have is an upper tail test because the alternative hypothesis is in the upper tail. So that tells us that the p-value is going to be the area to the right of our test statistic with 43 degrees of freedom. Okay, so now we will use our t-table to determine the p-value. So now we want to look for 44 or 43 degrees of freedom. And if we look in our table, 43 degrees of freedom isn't listed, so we're going to round down to the closest, which is 40 degrees of freedom. Okay, so now we want to locate where 4.015 falls in between for 40 degrees of freedom. So now if we look in our table, the very last value, we have 3.307. And so 4.015 will fall to the right of the table. Okay, so it's larger than 3.307. So let's write down the area of this value. Okay, so what the table tells us is that the area to the right of 3.307 has a right tail probability of 0.01. So let's draw out this probability. Uh-oh. Okay. So we're given that the area to the right of 3.307 is equal to 0.001. And now what we want is the area to the right of 4.015. Okay, so maybe let's try coloring this with a different pen. Okay, so the p-value is going to be the area to the right of 4.015. Okay, now since the area to the right of 3.07 is 0.001, then the p-value is going to be smaller than 0.01. Okay, so that tells us that the p-value, which is the area to the right of 4.015, is smaller than 0.001. So using interval notation, we could say that the p-value is between 0 and 0.001. Okay. So now we will compare this p-value to the significance level. Okay, so we're testing at an alpha level of 0.01. So if we compare alpha with the p-value, then the p-value is going to be smaller than alpha. Okay, so okay, so now, because the p-value is smaller than the significance level, we will reject the null hypothesis. Okay, so this tells us that we have sufficient evidence for the alternative. And recall that the alternative hypothesis was that the mean triglyceride level is higher than, for men, is higher than the mean triglyceride level for women. Okay, so there is sufficient evidence to conclude that the mean triglyceride level for men is higher than the mean triglyceride level for women.